Earth's surface is always changing. Rock is disintegrated and decomposed, moved to lower elevations by gravity, and carried away by water, wind, and glacial ice. Weathering starts the process by attacking solid rock at the surface. Next, gravity moves the weathered debris downslope. This step, called mass wasting, may range from a slow creep to a thundering landslide. Eventually, material that was high up a slope may reach a stream where moving water transports the debris away. Weathering, mass wasting, and erosion are called external processes because they occur at or near Earth's surface. The ultimate source of energy for external processes is the sun. External processes are responsible for transforming solid rock into sediment and are therefore a basic part of the rock cycle. Which arrows on the rock cycle represent weathering and erosion? Click on all that apply. To realize what a dynamic place Earth really is, just look at a photo of our nearest neighbor in space, the Moon. Its surface hasn't changed much for 2 billion years. Without an atmosphere and a hydrosphere, Earth's external processes could not operate. The Moon has no atmosphere or hydrosphere. Therefore, practically no weathering and erosion occur here. Unlike external processes, which lower the elevation of the land, internal processes are constructional, which means these processes increase the average elevation of the land in opposition to gravity. Internal processes derive their energy from Earth's interior. Energy from Earth's interior comes from the cooling of an initially hot planet and from the decay of naturally occurring radioactive isotopes. Drag each of the above process names to the proper category. Weathering processes are divided into two broad categories: mechanical weathering and chemical weathering. Mechanical weathering is accomplished by physical forces that break rock into smaller and smaller pieces without changing the rock's mineral composition. Unlike mechanical weathering, chemical weathering alters the chemical structure of minerals by removing and/or adding elements. Thus, chemical weathering involves a chemical transformation of rock into one or more new compounds. The concepts of mechanical and chemical weathering can be illustrated using a piece of paper. The paper can be disintegrated by tearing it into smaller and smaller pieces. Decomposition occurs when the paper is burned. In this section, you can explore 4 common types of mechanical weathering. Just click on any of the boxes above. When liquid water freezes, its volume expands about 9%. As a result, water freezing in a confined space exerts a tremendous outward force. When large masses of intrusive igneous rock, such as granite, are exposed by erosion, slabs begin to break loose like layers of an onion. Heating rock causes expansion, and cooling causes contraction. Repeated swelling and shrinking of minerals with different expansion rates may exert enough stress to cause mechanical weathering. Weathering is accomplished by the activities of plants, burrowing animals, and humans. For example, plant roots in search of nutrients grow into fractures, and as the roots grow, they wedge the rock apart. In summary, no matter which mechanical weathering process is involved, the result is always smaller and smaller pieces without a change in composition. To gain an understanding of any of these three common types of chemical weathering, click on the appropriate image. Just as sugar readily dissolves in water, so too do certain minerals. This example shows halite dissolving in water. The most common mineral group, the silicates, is decomposed primarily by the process of hydrolysis, which is the reaction of any substance with water. Everyone has seen iron and steel objects that rusted when exposed to water. The same thing can happen to iron-rich minerals. In summary, you have seen that chemical weathering processes produce new substances. This table lists the weathered products of some of the most common silicate minerals. Variation in the rate and degree of weathering can create many unusual and sometimes spectacular rock formations and landforms. This phenomenon is called differential weathering. Several factors can influence the type and rate of weathering. One factor that influences the rate of chemical weathering is the amount of mechanical weathering that has taken place. Breaking rock into smaller and smaller pieces increases the surface area exposed to the elements and therefore increases the rate of chemical weathering. One of the important rock characteristics that influences weathering is the mineral composition of the rock. Here you can see that the granite headstone is relatively resistant to chemical weathering as compared to the marble headstone. The marble headstone is composed of calcite, which readily dissolves in a weakly acidic solution. The silicate minerals composing granite are much more resistant. Silicate minerals are not all equally resistant to chemical weathering. Quartz is especially durable. Another rock characteristic that influences the rate of chemical weathering is the degree of jointing. Joints allow water to penetrate otherwise solid rock. Because rocks are attacked more on the corners and edges, they take on a spherical shape. Climate is another factor that influences the type and rate of weathering. For example, the frequency of freeze-thaw cycles greatly affects the amount of frost wedging. Temperature and moisture exert a strong influence on rates of chemical weathering. The optimum environment for chemical weathering is a combination of warm temperatures and abundant moisture.